Sendeyiz hocam.
Tamamdır. Hi, everybody. I would like to continue from state-of-the-art architectures. You will hear a lot of keywords or you will see comparisons between these architectures. I think a quick overview will help you to navigate this space because in some scenarios it really makes some difference. Just a moment, I need to stop my, yeah. So after BERT, and after it achieved SOTA with a big difference, many new models were suggested. Elmo got more popular, although it precedes BERT. RoBERTa, actually, it is a bit more saturated BERT. It is trained more. And there is some comments like BERT is undertrained. And RoBERTa shows this. If BERT had been trained more, it would work even better. XLMR, the multilingual models, actually BERT has a multilingual version as well. It is MBERT. Because it doesn't have a dedicated paper for it, it didn't become that focus of attention. But it is around, and many multilingual text processing systems or tasks started or using MBERT, at least for some comparison sometimes. And there is T5 and a couple of them, so like Albert. I will come to them. Then the next wave came in terms of size. Much larger models, which means much more word knowledge, common sense knowledge, much more language input. So these models are much better in comparison to this first level of language models like BERT, RoBERTa, or others. But these are a bit less adaptable. Although GPT-4, ChatGPT almost removed the need to adapt it. There is good platforms around it. It is much easier to use it. It is really not needed to understand all details to be able to use it. The more you understand it, is the better. Sometimes the architecture or building blocks are good to know. And until you know or learn them, you can still keep going. There are new tasks like zero-shot learning. Can a model predict what you ask it without you give any training data? Or what would happen if you give only a couple of examples and expect the model to mimic this behavior with different samples? So this kind of tasks are introduced. The technology was mature enough to incorporate or tackle these tasks. They were around a couple of years ago, but they were not performant. But again, in these days, it is getting much more capable of doing things. We see it with ChatGPT. I talked about RoBERTa. It is a bit better than BERT, and it is its only difference is the cycles of training, much more. More data is proved to help more, not just more data, but going over the same data more helps as well. There is XLNet, generalized autoregressive pre-training for language understanding. As I mentioned in the morning, new architectural, maybe not a novelty, but just a configuration is introduced, and it was shown to perform better for some type of tasks, or it is more compute effective, or it can generalize to more to longer sequences, because this kind of models has a limit on what is the length of the text they can handle, due to the when in BERT, for instance, the model gets too slow and in a linear algebra setting, the numbers become too small, so they start not to mean much. But each of these configurations help to improve some aspect of this paradigm. In BERT, there was you would respect the order from left to right and right to left, and you would predict the word in the middle, for instance. You would use context from different sites, and you would respect the order. But experiments show that, and this model, even randomly, without the order, like in a bag, if you put the words, the model will infer the right meaning in a vector space. So this is XLNet. It is a bit better than RoBERTa. Again, here you see you are getting closer to the limits of these models, how they can compete. Albert, again, new architectural experiments or configurations, and sometimes trying to not learn from one single, not from one single token, the replacement of one. We call it masking, and it is at the core of all these pre-trained architectures. It may have the missing part from all of the sentence, for instance. There's Electra as well in this line. And some transformers are better based on these masking strategies. They are seen performing better for certain tasks. For instance, Albert is for generative tasks was better. Another one, T5, it is Google, it is 2019. Maybe you hear it the first time, but it is a commonly used one, and actually an old one, relatively in these days. Even if it is from last year, we sometimes say, oh, it is old. New architectural developments allow to handle much larger sizes. This is the key advancement, because putting everything together start to exponentially be much more complicated, the communication, the update of the gradients. So therefore, some innovations or developments, algorithmic developments or memory developments had to be found. Electra, as I said, not only one single token, but all tokens may change spaces. So you, in an unsupervised manner, you just remove one word randomly from all the sentence in different iterations, and you tell the algorithm to learn this pattern. And it can make the data, it can learn from the data much more, because instead of just one word of masking, it get all combinations from one single sentence. Again, it was a quite good one, but it is used less. So we keep talking about larger sizes, much larger sizes, but at the end we have one single task, maybe a specific one, easy one, who knows. So distillation is introduced to have the models to distill the models to a much lower size after they are trained. Then you get a let's say, summary of the model, and it works much faster, sometimes 10 times faster. and you lose only 1-2% of the total performance. So if it is 97, it becomes 96. So and it works on your laptop. Not you don't need a server or an online service. So therefore, again, it is a quite good development. We use them; they work. Keep in mind, if you see a distilled model, you try it. One thing. Second thing, check whether it is distilled in the way you need, whether the distillation methodology or the task for distillation suit your context. What else? Again, distillation. I will just keep going, like many benefits, but if you can afford losing a couple of points of performance. There is new methodologies in these days. There is 5 at least instruction-based learning, in-context learning. Those are quite new this year. They came last year and the year before. We zero-shot and fifth-shot learning was popular. By zero-shot, I mean the model is learned entailment relationship. So a tree is a plant, this kind of relations. And then after enough examples, it starts to do what you want without you give any example to it. And there is multilingual versions of these data sets, and they are fine-tuned with this data sets, and they work. You can optimize them in this line. There was a shared task in our workshop. The fifth-shot learning is a bit more like, let's help the model, give it a couple of examples, then it would learn from it. So again, it is a fine-tuning. You change the model with these couple of examples. You update the parameters, and for instance, 10 examples, labeled examples. And at the end, your model should perform well in for your task. New one, like without touching the in-context learning, without touching parameters of the model, you give examples, and in combination of your input and these examples, the model tries to predict label of the new sample. More to come. Every month we hear about some development. There is you can just go to these stuff, read them. At least you need to be literate about understanding what may happen, what is happening, or what should you understand when you hear something like superhuman performance on certain task. Anybody think superhuman performance by the language models will be possible?
I have to unmute us. I think they can be possible in. What are the examples, Hocam?
Yeah, actually, by superhuman performance, when they talk about superhuman performance, it is on a data set. And if you ask a person and the machine do better on the reference data. But there is 2 sensitive things there. One, some tasks are subjective or dependent on the culture of the person or gender even sometimes. So what is right or wrong may depend. Both may be right, correct, but the reference data set may be encoding only one. This is one thing. The second thing, what was it? Language models cannot define a task. So they are good at differentiating things, not in conceptualizing the things, like coming up with a data set and compete on this data set with a human. So therefore, with these two bottlenecks, language models are only mechanic tools. So this is for you to think about whenever you hear about superhuman performance, because it is marketing, revenue-based dialogue. I want to highlight Hugging Face Transformers. Hugging Face is a company. Transformers is the library they developed to manage this kind of models, data sets, modules, libraries that help you adapt your systems, an online platform. So it is really the most comprehensive hub of deep learning in these days. And with one single parameter, you can try 10 to 15, maybe 20 different models on your task. So therefore, I think you need to be aware of it. It is the Transformers is the library, and you can go to the GitHub page. It has really a good references. I will show you the data, the models page. How you would search in it easily. If you get an account, you can upload your models or download much more or interact. You can just search for things like just, let's say, Turkish, maybe in the languages. I want Turkish models, and then you get the whole list of them, 581. You can get data sets. There is a library called data sets, and you can get these data sets very easily, or you can contribute your own data set, and people would use it and cite your work. You can filter based on the licenses, on the tasks, for instance, text classification or zero-shot classification. This is one of the early ones. You just enter your text in 104 languages it was, maybe number of languages increased, and give labels, and then it just tells you about, predicts the label of your input. And maybe it is not available anymore, but it was one of the first ones. Please go there, and when you want to use it in your Python environment, you just copy this one, this is string, and then it is ready to use. So you can easily do a batch processing. Here, it is only a demo. You do it for one single sample, manual. But if you have a data set, you can easily import it and predict all of the data set and understand or compare things. This is here. Actually, I wanted to show you BERT large MNLI. Let's say BERT large MNLI. It is multilingual. It is entailment-based model, and it is zero-shot. So you just enter any text. Let's say what text I can find. Environment, let's say Wikipedia. Let's find the events, current events. Let's find the less sensitive one. Yeah, the abolition of mandatory debt. Okay. And then you just say, and this can be done in multiple languages. And then you ask for the label. What is the label distribution? You can change these labels as you wish. You can mix languages. It can be in a different language. Did it work? It is one of the early ones. Don't be surprised if it doesn't work. But new ones work much better. Yeah, you should have this one. Please experiment with it. Actually, on this one has the most complete list. Normally on Hugging Face, there is a web page which has a limited number, but the most up-to-date list of the notebooks examples that can be opened in Colab as well is this one. And you just try or fine-tune things as you wish. I want to show you two things. Summary of the tasks. Not here. I want to open them in Colab. Victor. You just install it, run anyway. Okay, not Google, I see. They have a good training to give you a basic high-level introduction to these technologies. It is not a language-specific one, so you can quite comfortably follow it, and good to know. And I started with it, to be honest, to this to compare things, for instance. This is data sets. Yeah. Here, the most easy thing for you and good thing to try, there is a default, actually, or predefined tasks. And behind these tasks, there is a model. It is by no means assumed to be the best. It is just to show you. And by saying with this pipeline object, it combines all steps like tokenization or alignment after prediction. You don't need to do it. And then you just say, okay, I want this classifier to be sentiment analysis. You need to know these values from the reference library. And then you have your predictions. It is very easy, but for you, if you develop anything, package it in one pipeline object. We did this in traditional machine learning as well, in scikit-learn. It make these kind of models, which contains many steps in one. It makes them one single command. And this one single command helps to be exactly reproducible. It will register all configuration, all design choices, design decisions, and you can then transfer it or use it. Where is my prediction? Specifier should be here. I didn't run this one. Yeah, it should come. Yeah, it will download the whole model. And it cache it for the next runs. If you're on local, you will not need to. I want to say something about this. If the input changes, the scores may change a lot. Like, really. Again, this doesn't change, but one of the sensitive or hard issues in this kind of models, they are large black boxes, and sometimes with one single little thing, they behave unexpectedly. So you see it with your eyes. The whole sample should be classified in a certain way, but then at the end, with one single little difference, the decision changes. Keep this in mind. In these days, we are trying to decrease this kind of randomness, but and this is the reason why not everybody really just using this technology. They still have issues. What else I can say? You can change the model. Again, you will check the reference of the documentation of the library, what options are available. mostly whatever model from Hugging Face may work here. Some models are not optimized for this task, then it will not work. You would check for which tasks the model is optimized. You can, as I said, there are many data sets. They are uploaded there. You can get them from, this list can be obtained from the data sets. Hugging Face. It was here, models. You just go to data sets and search for it. Let's say Anthropic. This is a new wave of data sets, HHRLHF, and then use it. Look, it is 6 days ago, 2 months at most. So it is this type of data sets, even very new ones are there. So you see. Anyway, you just get the token and then you can get it in the format you want. Otherwise, in an experimentation setting or scientific publication setting, your preparation of the data and keeping track of all these steps is another problem. Therefore, many times we ask the authors, okay, can you give us the data set or what steps you applied? We don't get any precise answer. Even they provide us the code, maybe they run the code in an older version of the software and the results are just different. So therefore, facility or utility of this library is really immense. And there is a couple of options. What else I can say? Yeah, that is what I will tell you here. This is why it can work like this. With one single token, it can do all steps because it recognizes its configurations. There are many auto. When you see this auto, this means it checks the configuration itself. You don't need to track these steps or the configuration. Yeah, this is one thing. This is, let me see if I have anything else. Summary of the tasks. Well, I can't, just a moment, I will go just back and find it. This is quick tour. Honey. Yes, I have the notebooks now. No, I want to collab. Actually, we talk about this, no, not this one. This is the pipeline. Extractive question answering. You have the text and you ask the question, and the question should be from the text itself. So it is not generating any new token or any new answer. It just, it relies, so no hallucination, for instance. This extractive versus abstractive difference is really a key difference in these days because large language models are big black boxes and they don't explain why something is predicted in some certain way. Therefore, if it is abstractive or generative, then if you are lucky, it will not hallucinate. But it does, like ChatGPT, make up answers. Therefore, if you stay in the extractive area, in these days, it is a bit safer. You get the answer only from the text. This is the quality of it. Language modeling, you can ask, for instance, when you write in these days in Gmail, you get suggestions in a bit, like you write 3 words and 2 more words are suggested. If you press the left button on your keyboard, you get these words. Otherwise, you keep writing and the system keep suggesting, storing a lot of information for you, or these patterns are known to the model.
Sorry to interrupt, but we cannot see the small code, so maybe
Sheval, tell me.
maybe we can adjust a little bit bigger the code and little writing, because we cannot.
I can try to make it a bit larger, but you should just, I have the links, they are with Akunoja. You should go over it yourself, guys. I will make it larger. You are right in this respect, sorry. Yeah, I can come a bit back. The sequence classification. You have the sequence, which is a text, we call it sequence, the whole string, and then you get a label for it. What else? You have the extractive question answering. You give the question and it extracts something. One pitfall or disadvantage of these models, even if the answer is not in the text, it gives you the most probable string, substring, which is really, so you don't know whether it is really makes sense. So it falls in this randomness if the answer is not there. So it always, these prediction models, we call it prediction. Therefore, for all machine learning models, we call it prediction. The model predicts. And if the answer is not there, it just make a best guess. For extractive things, especially. For abstractive things, it may make up things.
Sorry again. Işık Topçu is here. I'm admitting her.
You mean okay, she's in the session. What else? You can have, you can ask for it to complete your writing. The model, many platforms has already incorporated these tools in them. For instance, if you start to write an email, the mail clients start to suggest you phrases. Another thing, we use this masking thing, is to evaluate the quality of the model, if it completes it in a of good information encoded in it. So when we compare models, we use these capabilities. What else? Yeah, text generation is used for abstractive things, abstractive summarization, abstractive question answering, and in machine translation, because in machine translation, the output should be generated based on the input. It is main class of tasks. What else? Name entity recognition, if there is a company name or person name or place name, it will be identified. And the model should be an ER really. And a default one is a language model is that is trained, fine-tuned for this specific task, is waiting there for you, and it will be doing the prediction. And you can change the model. If the tokens in these models is a bit less readable to human eye. So it is based, it's a statistical longest match or most salient character sequence. So therefore, the row tokens would look like split in two. And this means it is split from left. The end output, the pipeline object I just mentioned, put these stuff together, or you would have the code yourself in your system. What else? NER, summarization. This is you get a shorter version of the task, translation, and it is all like you see. You type the token and then automatically the relevant model is brought. It is rarely very useful for, these defaults are rarely useful for your task, so be careful. But a good start, I would say. What is here? Yeah, maybe this is a bit more generic translation model. Like I said, BERT. And audio and image all are together. One and image. So this image and the audio things are put separate these days, but just all are vectors and you can combine them, which opens up multitude of opportunities for multimodal processing. An image plus a text, or you may use you can ask about a caption for a figure, for instance, or image, and vice versa. So all are possible in these days, and they start to really work with GPT-4 especially. But they are, again, the bigger and the bigger the model is, the more black box it is, then at the end, almost none of the issues are really resolved. Hallucination is there, misleadingness is there. I mean by misleading, when it in an extractive question answering scenario, it really just tell you some string, a random string, if the answer is not there. Therefore, the danger is higher. Any comment or question specific to this Hugging Face or libraries?
Hello, thank you for the presentation. Questions we can take. I guess everyone is a little bit tired because we came from a long road, so I don't think everyone comprehend everything. We should probably just look around the notes, and Akın Hoca already shared the files with us. Thank you so much. And thank you for your time. Wonderful presentation.
Perfect.
So I guess
I'm happy to talk to you guys. You have already did a lot of traveling in Istanbul, so
yeah, yeah, traveling information, just very compact program. So thank you very much, and yeah. I hope to see you soon.
Keep in touch. You have my email address, and I will be happy to discuss anything or be in touch.
Yeah, thank you, Hocam. Have a good day.
Bye-bye.